Hello, I'm here to talk about least squares regression and the normality assumption. Least squares regression is a tool that we use to fit aligned data in a way that allows us to make predictions and understand the data better. But the nice properties and insights that we can gain from least squares regression are only relevant if we can satisfy the assumptions of the least squares regression model with our data. These assumptions are numerous, but the one that I'm going to be talking about today is the normality assumption. The normality assumption has to do with the random errors in our model. Our residuals have to follow a normal distribution. And in order to validate this, we have different methods. But let me talk about the importance of it, because if you do not validate the normality assumption and it is violated, yet you use the data anyway, you could have very off predictions. Not to mention, the model itself is foundationally dependent on whether those errors are normally distributed or not. If you don't test it, then the model could be completely meaningless. So that's the importance of why we test for it. Finally, the two ways that you do are once you fit your model, you can test it graphically using a box plot of the residuals, but what is typically used is a normal probability plot or QQ plot that fits the residuals in your data against the theoretical quantiles of a normal distribution that it is theoretically following, and how well it hugs the line that indicates that normal distribution. The data itself indicates how normal the data actually is. If it follows it closely, it hugs the line throughout, except maybe at the ends or only a few small portions, but most of the data tends to follow the line, then you have normally distributed data and you can proceed with your analysis with respect to the normality assumption. If the data is drastically off the line in parts, has a lot of outliers, that is a situation where you would reject the normality assumption and attempt to adjust your data to fit the normality assumption. And then there is another way to test for normality using exact tests, hypothesis testing, the null hypothesis being is the data is normal, and the alternative being that the data is not normal. An example is the Shapiro test, which we've used, and you can choose your significance level like any other hypothesis test. Say it's 0.05, then if your p-value is less than 0.05, you reject the null in favor of the notion that the data is not normal, and then you go for remedial measures. Both methods are good, both work, and oftentimes absolute confirmation is better gained through doing both of them. But once again, the normality assumption is crucial to the least squares regression model, and we must consider it anytime we are fitting a line to the data as such.